Hello ladies and gentlemen, this is another in my series of geometry lessons for you guys. Where are we at? Well, should have finished everything through Unit 4, Lesson 13. What we're getting close to is the end of Unit 4, and I know that when I'm recording this one, we are getting close to a holiday, so what we need to be doing is thinking of getting that Unit 4 test done before the holiday so that you're not having to do it while you're on the holiday, okay? Don't forget, you can all do quiz corrections. Get those corrections into me. It does add points into your grade. You need to get those done so that you can get your grade as high as you possibly can. I'm having a few people that are having grades that are being locked in at zeros because they are not working on the things that they need to be working on. Remember, we close things off after 4 weeks, so you want to get them done well in advance of that if you possibly can. So, what are we looking at? This lesson is over constructing regular uh, polygons in one form or another. Now, what I want to talk about first is on Sketchpad. Sketchpad is that software that we loaded back in Lesson 1, Unit 1, Lesson 2. It's a software that you can use if you want to, but one of the things that is always confusing people is, well, how do we get a perfect ninagon? Well, one of the things you ought to remember is that there are 360 degrees in the external angles. And if we rotate a line segment, and that's one of the things that you can do in Sketchpad, is to rotate an angle, and you can rotate the angle a certain number of degrees. If you rotate it you know, a number of degrees, you get an angle. You use that as an external angle. You keep doing that all the way around, and you wind up with a whatever size object that you're wanting to be looking at. Okay? So I'm going to demonstrate this a little bit. So I'm bringing up the software here. It's going to take a couple seconds for it to start up. Okay? But what I'm wanting to point out to you is if I'm looking to get those external angles on a ninagon, I would take 360 divided by 9. I'm looking for a 40-degree rotation. Pentagon, a 36-degree rotation. A 24-gon, 15-degree rotation. A 72-gon, I would rotate it 5 degrees every single time. Nope, that's not what I wanted. Okay, it didn't bring up what I wanted there, so hang on a second while I bring up the right software here. That's what I'm wanting. Okay, you can see it starting up here, GeoGebra. Okay, and here's my sketch pad right there. Okay, so what I'm going to start off with is I'm just going to draw a little line segment. Okay, I'm going to start with a point right here. I'm going to draw a little line segment. Let's see here, start with a line segment right there, and I'll draw a line segment out here that's this long. Okay, it goes from A to B. Now, if I want to rotate that, what I'm going to do is I'm going to come over here to angle, and it's got in here, oops, there it is. I'm going over here to this one. It says rotate an object around a point by an angle. So if I select that and I select, it's telling me select the object to rotate. I'm going to select the line segment right there. Okay? And then select the center of rotation. I'm going to select point B as my center of rotation, and I want to rotate it 40 degrees. I'm going to change this to say 40 degrees, and I'll go counterclockwise. That'll be fine. And I'll say OK. And it created another line for me. Cool? You see what I'm doing there? So if I do that again, I want to rotate an object around a point. Well, what object do I want to rotate? I want to rotate this one, and I'll rotate it around. I didn't put my other point on there, so around that point right there, and there's not a point there, so it's giving me a headache about that one. Okay, if I want to rotate around that point right there, and I'm going to go 40 degrees counterclockwise, it gave me that line right there, which doesn't make any sense, so let's get rid of that one. Delete, gone. Okay, what I didn't get in this first line was my distance. Okay, so if I wanted to go that distance here, I need to make certain that I'm rotating that point around it. So what I'm going to do is I'm going to go the other way, and I'll show you how it works going the other way. If I'm going to rotate, I want to do this one. rotate an object around a point by an angle. I'm going to rotate that point around that point 40 degrees, and I'm going to go clockwise this time, and it should give me a point down here. Now I can connect those two with a line segment from A to B. Okay? Now if I want to do it again, I'm going to do it again. I'm going to rotate, get the right one, rotate an object. I'm going to rotate that point, right? Let's see here. I want to rotate that. I want to rotate that point around that point 40 degrees clockwise. Should give me a point right there. Nope, not the point I wanted. I try it one more time here, Charles. Rotate this point around this point 40 degrees clockwise. There it goes. Okay? And I'm getting these angles. You can see how these angles are all working out, right? From A, come on, draw my line segment. From A to B. Now I can grab these line segments and move them around and things like that, and I'm going to be getting the sides of my octagon by moving them around, getting them to work. You can experiment with this in the sketch pad. This is one way of getting some objects and getting some lines to rotate. Obviously I'm not real good at it. I've seen it done, and I can show you videos that show you how to do it, but it's one of those things where if you're using that sketch pad, you can get it to draw some objects for you. But you need to be able to construct things when you don't have that sketch pad too. So I want to talk about constructing a square. So what I did is I drew a line segment. I put A and B on there, and I took my little compass and I drew a little mark out here and a mark out here. Without changing the length on my compass, I put the point at B and I connected those two together. And I've got, little marks here. Well, I can label those as C and D if I wish, but I'm just going to leave them like that for right now because I'm just going to connect them with a line. Now, what I just did was create a perpendicular bisector. That's what that's called, is a perpendicular bisector. That's the construction for a perpendicular bisector. So I've got perpendicular angles right there. How do perpendicular angles help me at this point? Well, one of the things about a square is that the diagonals are perpendicular. If I use this point right here as the center of a circle, I can draw a circle around the outside, around out like this, and then connect the points where it hits those diagonals, and I will get a square. That's the whole concept that we're trying to get to here is this technique of constructing a square is one that will work. Why? You built perpendicular bisectors. These are perpendicular diagonals. These are perpendicular to each other. You made a circle that makes all the sides the same length because they're going from these points here. It also made certain that these were bisected. Why? Because the distance across this way would be the same across the circle. Okay? And these would be the same. It made all those diagonal parts there the same. Those are all properties of a square that you need to have. By doing this, you're guaranteed of getting a square. A lot of people say, well, I'm going to draw a circle, and then I'm going to draw on the outside of the circle, and I'm going to draw a line out here like this, and it's going to be, hit just one point on that circle, and then I'm going to come over here and I'm going to draw another line that's just going to hit one point on this circle. The best you can hope to get this way is a rhombus. Okay? The worst you get would be some sort of a quadrilateral trapezoidal figure. Okay? So you got to be careful. Drawing on the outside of a circle like that, not a good plan. It will not give you the circle that you're going to need to do. Why am I stressing this so hard? Guess what? You're going to have to do this. You're going to have to demonstrate this for me. And you're going to have to tell me why this works. The best way to demonstrate it, even though I don't have a compass, I'm doing this on a computer. I don't have a pencil here. I simply drew two lines, okay? I indicated the fact that they were perpendicular to each other by using these little circular marks out here, showing that I had tried to bisect, or that I tried to make a perpendicular bisector. I then drew a circle on the inside around it using that center right there, okay? By drawing that circle around the outside, I'm trying to show that the diagonals are all going to be the same length, and uh, the sides are all going to be the same length. And I did this without using a compass at all. If you're trying to do this in Microsoft Word, yes, you're going to do it as a part 2 assignment. If you're trying to do this in Microsoft Word, you can insert shapes, insert the shapes so that this works. Make certain you diagram it out that way, describe what you're doing, and you will show how to make a square. That's what you're going to have to be doing. So I want to make certain you all understand, and I'm trying to be as clear as I possibly can. You will have to do this, and it's points for you. So know how to construct a square. Okay? So that's all this lesson. My secret word for today is Chiefs, as in the football team. They're doing very good this year. One of my favorite teams. So you can root for the Chiefs. Rah rah. Send me a K-mail. Nope, you don't need to send me a K-mail. That's just for Class Connects. Okay? So, what I do appreciate is you all telling me that you are in geometry when you send me your course information, when you ask questions, because sending that to me helps me understand what's going on. Okay? Helps me find where your records are a lot faster. So, I'll look for you next time. Talk to you later. Bye.